Guys, welcome to Foundations of Real Estate Financial Modeling. Today we're going to be going over what's a dynamic amortization table and how to put one together. In the past, we went over the three types of amortization. So we covered constant payment method, the interest only method, as well as the interest only method. Here we're going to see how we can put all of them together into a single table, which will allow us to compare the differences, compare and contrast the differences, and we'll wrap it up with a sample problem. So let's jump into it. Like I said, we're gonna go over a dynamic amortization table, and what this is a comprehensive table that has the capacity to quickly change the amortization structures for a quick comparison, and we can compare how much we paid on interest, how much we paid on principal, what was the total amount of payments that we made, and we can compare that quickly within one single table. With that, we can just jump into our sample problem. So we have a loan with a principal balance of $12,550 with a 4.25% fixed interest. The analyst must consider the three basic loan structures: constant payment method, the interest only, and the custom approach. They want to know how much we paid in total interest in each structure, what is the total payment, and what was the payment in the first month. And we're going to assume an overall loan period of 12 months. Okay, so let's get to it. So here I already have it built out, but let's get rid of this information so that you see how this gets put together. Let's get rid of this. Clear all. Okay. Leave that there. So here we have our inputs, right? So our principal is that of $12,450. Our interest, it was said it was going to be 4.25% according to the loan, and the interest per period is just our interest on the life of the loan divided by the tenor, which it's another word for the periods in which we pay, make a payment, right? That's basically what it is. And then here we have the loan product. So that's the loan product type, and here we set it up a quick schedule of what we're gonna mean when we say this is a 1 or this is a 2 or this is a 3, right? So if there's a 1 here, then we know we're gonna be talking about the constant payment method. If it's a 2, we're gonna be talking about the interest only method. If it's a 3, the custom and things of that sort, right? So we want to be able to do here is be able to have a list with 3 numbers, 1, 2, 3. If you don't know how to do it, it's super simple. If you're in your home tab in the ribbon, just go to the data section within the ribbon, go to data validation, allow, you go to a list, and then we can just say we want 1, 2, and 3. Okay, so now we have a list here. We can throw 1, a 2, and a 3. And the way we're gonna set this whole thing is we're gonna use a choose function, and the choose function is gonna reference the loan product type in this cell. So if there's a 1, then the choose function is going to auto-populate all the values in here. If it's a 2, it's gonna change the values in here, and if it's a 3, it's gonna do the exact same thing. But you'll see that here soon. Now, let's start filling out the beginning of the period balance, which is the same for each single amortization structure that we use, which is at $12,550. Okay, and then we jump into the principal paid. When we do that, we already need to think about how it's gonna change with what structure we have, right? So here's when we use the choose function. This is where it comes into play. So we'll do choose function, and then this is the index number, and the index number is just a cell that we're going to reference to dictate the values within our table, right? So that would be this one right here, C10. And then we have value 1. So value 1 means what's the value for what would be number 1 in cell C10. So for us, it's the constant payment method, right? From our previous videos, you would know that there's a function within Excel that can help us calculate the payment that's gonna be paid throughout the life of a loan. It's the same one, it's constant, and the function is ppmt. If you're not familiar with it, I recommend you go back to the videos and get familiarized with it, but we're gonna go quickly through it right here. So the rate, this would be what we're paying per period, so that's the 0.35%. This PER, per, that's just an abbreviation for period, and it needs to correspond to the period that we're making the payment, so it's period 1. The number of periods, that would be the tenor, which is 12, and then the present value, that would be the loan, basically, that we got at the beginning, the present, the very first period, right? So that's a 12,550, and we are gonna add a negative here. If we don't add a negative, we're gonna end up with a negative value, so we just put a negative there to close it and close parentheses. So for value 2, we know that value 2 is linked to the interest only, and when it's interest only, we don't pay any principal throughout the life of the loan, so it's going to be a 0, right? And then we jump into the last one, which is the custom approach. The custom approach just means that we're going to be paying a different percentage of the principal throughout the life of the loan. In this case, in period 1, we're going to be paying 5% times the original principal. Okay, then we can close our function, and that's it. Right now it's a 0 because we're showing a 2, which is basically meaning that's interest only, so that makes sense. $0 for principal payment. So if we make changes, the value changes to 0, 3 changes to 7.50, which is the 5% of the 12,550, right? Okay. So we're going to want to drag that function, but before we do that, we need to make sure that we have some of our cells locked within the function. So we obviously want to lock this one, C10, because we don't want that to move. We want to lock the rate, because if it's a 1, meaning we're gonna have a constant payment method, the interest per period is the same 1, so we're not gonna want to change that. The period, we do want the period to change as we drag down, so we're not gonna lock it. The number of periods in the loan, we're gonna want to lock it. We know that that's 12 periods, and that's not gonna change. And the present value is not gonna change either. That's always the same. We're just not gonna change that. Okay. So 0, nothing to lock there. It's hard coded, so nothing to lock. Here, G13, which is this cell, we do not want to lock it because this value we want it to keep changing and going down the cells, so we're not gonna lock that one. But we are gonna lock cell C6 because it's always the payment here, so it's gonna be a percentage of the principal, right? So it's gonna be 5% of 12,550, or it's gonna be 10% of 12,550. So we do need to lock this cell. So we'll go ahead and do that. Lock it, and then we can start dragging down. Simple. Okay. Interest paid, I can just change this to 1. The interest paid, it's the interest per period, right, which is going to be the same 1, times what we have the beginning of the period. Okay, so in this case it's $44.45. We want to lock the interest per period, as we know that's going to be the same no matter what. We can drag this down now. It's ready to be dragged. And at the end of the period, remember that we subtract what we paid in principal from what we had at the beginning of the period. We don't subtract the interest because that's a separate payment, okay? So there you go. And then what we have at the beginning of period 2 is what we ended up with at the end of period 1. So we can just reference those cells like that, in that manner. And now we can start dragging the rest of the cells, okay? Dragging, okay? So right now what we're looking at, it's a table showing the constant payment method. As you see, it ended up in a 0, nice and tight, which means that we did it correctly. It's a good math check. It worked. Right, now let's move to the second one, to the second loan product, which would be the interest only. Here we see that we didn't pay any principal, which makes sense because we're just paying interest, which is the same because our principal never went down throughout the life of the loan. So perfect, that makes sense. And then custom, last one. We can see here that our principal changed as our amortization percentage changed on the right, so that makes sense, and we ended up with a 0, which is another good check that we ended up with a nice and tight table that's mathematically correct. Okay, so we're good on that sense. Now they want to know what is the total interest paid in its structure. So total interest paid, we'll just do sum, and we're gonna highlight the column with all the interest, and this is gonna change as you change loan products, right? So right now we're showing the custom section. So if we change it to 2 to the interest only, it changes to $533. If we change it to the constant payment, it changes to $290, right? So it's the formulas are working well in tandem with our table and our choose function. So total payment, this is going to be a tricky one just because you need to consider what happens in the interest only, okay? But in general, you would do sum of the principal plus the interest, okay? And then we're going to add where we left off at the end of the period. The reason why we're doing that is because in the interest only payment, so if we change this to 2, right? If you didn't add what's left at didn't add this cell, what's left in this cell, then you would only have the same as the total interest paid, which is not true, right? Because we would need to pay the principal at some point. So you have all of your interest paid during the life of the loan, but then at the very end of the loan, you have a separate payment known as a balloon payment, which would cover all of the principal paid. So if we don't add that cell, like I said before, you're gonna end up with just the interest, which is not accurate, and it doesn't affect our other loan products because they're 0, right? So we're just adding 0, so it doesn't affect either the constant or the custom approach. So there you can see how it works. And then they want to know what was the first payment in period 1. That's pretty simple. Period 1. We just do equal to the sum of the principal plus the interest. Oh, sorry guys. Sum. So for the custom, we paid $671. Interest only, we paid $44. And constant payment, we paid $1,000. And that's it, guys. Super simple. Appreciate you guys checking the video out. If you liked it, didn't like it, comment, subscribe, let me know what you like, what you didn't like. If you think it's a good video, please like it. Let me know if there's anything else that you would like to see. Interested in hearing your opinion. With that, I'll leave you guys to it. Have a good one. Stay safe out there, okay? All right, bye.